Imaginez this. You wake up tomorrow and instead of standing on Earth, you're teleported right onto the surface of the sun. No warning, no spacesuit, no shield, just you face to face with a giant ball of fire that has been burning for 4.6 billion years. The question is, could you survive even 1 second there? And believe it or not, there is one shocking twist about the sun's surface that most people don't realize. I'll reveal that near the end. Now, let's set this up. The sun looks like a fiery circle in the sky. But what's really waiting for you if you could somehow get close? Would you instantly vaporize like paper in a furnace? Or is there more to it? Here is a thought. If sunlight feels warm here on Earth 93 million miles away, then what would standing right on the source actually do to your body? Alright, let's dive into it. Daydream for a moment. You appear on the sun's surface, or more precisely, the photosphere, the outer visible layer we see glowing from Earth. Temperatures there, about 5,500 degrees Celsius, or nearly 10,000 degrees Fahrenheit. That's hotter than molten lava. To put that into perspective, if you tossed a steak on that surface, it wouldn't grill, it would disintegrate in a fraction of a second. So, what happens? The very instant you arrive, the air, or what little there is, would tear away your breath before you even thought about inhaling. Your skin would flash burn instantly, peeling away like paper held over a blowtorch. In less than a blink, every ounce of moisture in your body would vaporize. And your bones, they'd turn brittle like ash scattered in the wind. But here is the real kicker: you wouldn't even technically get to stand on the sun. Because the sun isn't solid. It's a swirling ball of plasma, basically charged gas. It'd be like trying to stand on boiling soup that is hotter than anything on Earth. Imagine falling into an endless ocean of fire that's hundreds of thousands of kilometers deep. Not exactly a safe vacation spot. Now let's widen the lens. Say you somehow hovered there for more than that split second. The sheer intensity of radiation would bombard you from all sides. Remember, the sun releases more energy in a single second than humanity has used in our entire history. You'd be hit by ultraviolet light, X-rays, and gamma rays strong enough to shred the very DNA in your cells. Here's a little riddle. If one candle can light up a dark room, how many candles do you think the sun is worth? The answer: about 10 septillion candles. That's a number with 24 zeros. Hard to picture, right? That's why even being near the sun, not on it, just near it, would be like standing inside the beam of a trillion nuclear bombs going off at once. And yet, here's the mini suspense. Hook the sun's surface, for all its horror, isn't even the hottest part. Stick with me, because what's above the sun's surface is even stranger. Fast forward a bit. Imagine not just your body, but entire machines built by humans, probes, satellites trying to get close. NASA's Parker Solar Probe, launched in 2018, is designed to skim just 4 million miles from the sun. That sounds far, but in cosmic terms, it's brushing right up against the flames. To survive, its heat shield withstands temperatures over 1,300 degrees Celsius. And here's the surprise: it's working. The probe is sending back real data as we speak, giving scientists clues about how the sun behaves. But let's play with the extreme edge case. Suppose humans somehow invented a sunsuit, a material that could resist unimaginable heat. You land, protected, and you manage to last 1 second. Could you wave, snap a selfie, then teleport back? Well, even if your body was shielded, you'd be crushed by another invisible danger: the sheer gravity. The sun's mass is so massive that you'd weigh 28 times more than you do on Earth. If you weigh 70 kilos here, you'd suddenly feel like you're carrying nearly 2,000 kilos. You wouldn't be able to move an inch. And here is the myth-bust moment. Many people imagine the sun as a giant fireball burning like wood or coal. But that's not true. The sun isn't burning at all, it's fusing. Nuclear fusion is what powers it. Deep inside, hydrogen atoms smash together to form helium, releasing enormous amounts of energy. Models disagree on the exact pressure inside, but some estimate it is like stacking 330 billion Earth atmospheres on your head. That's the engine that lights up our sky. Now, about that hidden fact I teased earlier. Ready? The weirdest part about the sun is that its outer atmosphere, the corona, is actually hotter than its surface. Sounds backwards. Right. The photosphere, where we'd stand, is about 5,500 degrees Celsius. But just above it, the corona can soar to over 1 million degrees Celsius. Imagine stepping away from a campfire and somehow getting hotter instead of cooler. Scientists still don't fully understand why, though magnetic fields likely play a role. This is one of those mysteries that makes the sun endlessly fascinating. So, let's flip this back to you. If survival on the sun's surface isn't even remotely possible, what does this teach us? For one, it shows just how perfectly Earth is positioned. We orbit at the right distance. Not too close to burn, not too far to freeze. Astronomers call it the Goldilocks zone. Too hot, too cold, just right. Makes you wonder if our sun is this dangerous. What about stars? Even bigger, hotter, and more unstable out there in the galaxy. Let's break it down into quick takeaways. First, 1 second on the sun equals instant vaporization, no chance of survival. Second, the sun isn't solid, so standing on it is like standing on fire itself. Third, the real mystery isn't the heat you see, but the even hotter atmosphere above it that scientists are still puzzling over. Now, here's where I ask you to imagine. If the sun is this extreme, what happens if we try something just as bold but on the opposite end of the spectrum? What if, instead of the sun, you found yourself on Neptune, a frozen giant where sunlight is barely a whisper? Would you freeze solid before you even blink or discover something stranger? If that sparks your curiosity, hit that subscribe button. Every week we take wild what-if scenarios and ground them in science, history, and imagination. And if you've made it this far, you already know this is where things get interesting. So, here, that's the cliffhanger to leave you thinking. If 1 second on the sun is enough to destroy you, what happens if you spent 1 year in complete darkness, no sun, no light, just endless night? Would humanity adapt, or would the world unravel?